Okay, good evening, guys. Assalamu alaikum. Welcome back to Inspired Teens Grade 10 Mathematics, where in today's lesson, we'll be continuing with functions. Okay, so I am recording this a little bit earlier, okay, so do keep that in mind. But yeah, nevertheless, hope everything is going well and everything is smooth and you guys have access to the video quality. Okay, so last time we talked about what exactly? Last time we spoke about the parabolic function, and today we're going to start with I don't know why the audio. 1 second. Apologies. Let me just make sure the sound is working. Just give me 2 minutes, sorry. Okay, perfect. Right. Now, so today we're going to talk about the hyperbola function. Okay, so we did straight line, parabola. Now, today we're going to talk about hyperbola and exponential. So the equation for a hyperbola function is y is equal to a over x plus q. So if we remember correctly, for quadratic, it is y is equal to ax squared plus q. But in this particular case, we have y is equal to a over x plus q, okay? Where a still helps us to determine the shape. So this still determines the shape. Sorry, let's do this. Okay, and this case, what is q? Okay, q, okay, in this q is something new. We haven't learned about it before, okay, but q is an asymptote. Okay, and more specifically, q is a horizontal asymptote. Okay, so essentially what is an asymptote? And we'll do some examples of functions, okay? But an asymptote is a line or a straight line that our function or our graph never touches. So, sorry, let's just edit this example a little bit. Okay, let's say that's our x-axis. And we have this guy right here. 1 second, sorry. Let's do this. Let's do this. Let's do that. Okay, there we go. So in this particular case, right, this is what the function might look like. Sorry. Okay, here we have a function that looks kind of strange. Okay, it has two parts to it. It has two parts to it. One is here and one is here. Now you'll notice that there's this dotted line. Okay, that's a horizontal straight line. And essentially the graph never touches it. So this is the shape of a hyperbola graph. This dotted line is the asymptote and continues forever and forever. And this straight line also continues forever and forever and gets close to the asymptote, but will never touch it. So it gets close to it, but will never touch it. It's difficult to sort of comprehend, but we just have to have that understanding. It gets closer and closer to it, but never touches it. Okay, as close as possible, something we can't even imagine. Okay, we also have a vertical asymptote, which we don't have to know right now exactly, but for all of our graphs that we'll do in grade 10, the vertical asymptote is the y-axis, actually. This is our y-axis, this is our x-axis. So the vertical asymptote is always the y-axis. So our hyperbola functions will never touch the y-axis. They'll never have a y-intercept. Okay. However, they can have an x-intercept, okay, because this line can move. Okay, the asymptote can move, and we'll do different examples of how to draw that out. So keep in mind, actually, the equation that you learn next year will be y is equal to a over x minus p plus q, where p, okay, is also an asymptote, but it is a vertical asymptote. Okay, imagine that p was 0. The equation would look like this. Y is equal to a over x minus 0 plus q, which is essentially y is equal to a over x plus q. So for all the examples that we do, p is actually 0, but we don't need to learn about p just as yet. That's just for us to know. So there's technically like a plus 0 there, which gives rise to, so by the way, okay, this also horizontal asymptote is basically also a y asymptote. This is a, why is this doing that? It's a y asymptote as well. Oh, my screen is frozen. Let me reshare my screen. I have no idea what's going on. Sorry, trying to display it nicely. It's not working with me. Okay, there we go. Okay, hope that everything's fixed and that you can see my screen nicely. But yeah, okay, essentially that is the case. Okay, we have A, which determines the shape. So we can actually see the example here. Let's do the same thing here. We just patch it up a little bit, make this that. Okay, and then create an x-axis and move it all a little bit up. Move this there, do this there, do this there, like that. So this, arrange, 25. Okay, so yeah, so A determines the shape. So remember when we did parabola, when A is greater than 0, we have a smiley face. When A is less than 0, we have a sad face. So in this case, in this function, when A is greater than 0, we have the function top right and bottom left. When A is less than 0, then we have top left and bottom right of our asymptotes. So just keep in mind that we do have both. We have a vertical asymptote which is an x asymptote, and this has the equation x is equal to 0. And that is the equation of the y-axis. Okay, we also have a horizontal asymptote. And this here is y is equal to q. Whatever the value of q is is our horizontal asymptote. Keep in mind, okay, that the vertical asymptote is an x asymptote and the horizontal asymptote is a y asymptote. Okay, because vertical lines have the equation x is equal to and horizontal lines have the equation y is equal to. Okay, so yeah, that's important. Cool. Am I missing anything? Of course, a can't be 0. Yeah, so let's have a look at this. Q is a constant but shifts graph up or down the y-axis. So yes, depending where I move Q, this line would move, and of course the whole function would move. Asymptotes, x is equal to 0, y is equal to 0, values that make the function undefined. Okay, it's not always y is equal to 0, but it's always x is equal to 0 because we're not dealing yet with a vertical asymptote. Right, this is important. The domain is x is an element of reals, but x is not equal to 0. And the range is y is an element of reals, but y is not equal to q. Okay, 1 second. Right. Now, axis of symmetry, okay? We'll discuss the axis of symmetry in a second. Okay, so each graph has an axis of symmetry, right? And its y is equal to x plus q and y is equal to negative x plus q. So if we have this as our function, okay, if we have this as our function, let's have a look at what would the axis of symmetry look like. It always passes through, the axis of symmetry always passes through this point right here. Wherever the asymptote meets the y-axis, it looks like this. Okay, both axes of symmetry pass through that point. So an axis of symmetry is essentially same like parabola. If we have to fold it in half on this dotted line, they would touch, the graphs would touch each other. So if you had to fold it across this line, the graphs would touch each other, right? So this one here has a positive gradient and has a positive equation y is equal to x plus q. And this one has a negative gradient. This is y is equal to negative x plus q. And q is the value of our horizontal asymptote. This equation is y is equal to q, whatever it may be. Okay, so those are the axes of symmetry. Now, let's go ahead and do an example of sketching if we are given the formula. So the steps are to determine the asymptotes. Okay, x is equal to 0 is always going to be the vertical asymptote, and y is equal to q is always going to be the horizontal asymptote. Determine the x-intercepts, determine the shape, and then use a table method to plot at least 3 other points. Now, let's have a look at it. Sketch the following graph showing all the intercepts with the axes and asymptotes. So right here, we have A as 3. Okay, A is 3. So A is greater than 0. What about Q? What is Q? Q is equal to 0 because here we have plus 0. Okay, there's no Q. It's negative 3 over x. A is actually not greater than 0, but we'll get to that. It's negative 3 over x plus 0, sorry. A is actually less than 0 because of this negative here. Okay, negative 3. Okay, and there's no q. It's like having plus 0. So the horizontal asymptote, remember, it always has the equation y is equal to q. So now the horizontal asymptote is y is equal to 0. And the vertical asymptote is always, for now in this grade, x is equal to 0. So we draw up a little function. Okay. And we know our asymptotes. Okay. Our asymptotes are x is equal to 0 and y is equal to 0. So those are the axes essentially. All right. So remember, this is our y-axis. This is our x-axis. Okay. And if we want asymptotes, y is equal to 0 is here on the x-axis. And x is equal to 0 is here on the y-axis. Okay, so our axes in this case are the asymptotes, so the graphs will never touch there. Okay, and then we know the shape A is less than 0. So just remember this, when A is less than 0, then we have top left, bottom right. Top left, bottom right. So we don't have to have it looking exactly like perfect. You don't have to have it look perfect, but it must just be relatively similar, some kind of shape that looks like this. So that's what it looks like. And this is what it looks like on this side. So of course, obviously you'd need to go ahead and calculate the x-intercepts. Okay, we determine the shape, but here we're going to have no intercept because both of the axes are asymptotes. So how can it touch? It won't touch the axes because the axes are asymptotes. Okay, let's have a look at this example. Okay, so then they say, okay, cool. All right, cool. Let's look at this example, right? Sketch the following graph with all the intercepts with the axes and asymptotes. So step number 1, determine the asymptotes. So firstly, horizontal asymptote is y is equal to q. So therefore, for our situation, y is equal to 1 is our horizontal asymptote. The vertical asymptote is always, for now in this grade, x is equal to 0. So we can go ahead and just draw up a little thingy. All right. Now let's draw our asymptote. So firstly, x is equal to 0 is on the y-axis right here. That's the vertical asymptote. The horizontal asymptote is y is equal to 1. So let's say it's somewhere here. Let's say this is where 1 is on the axis. This is 1. This is our y-axis. Wait, let's just see. This is our y-axis. This is our x-axis. You can even label this, say y is equal to 1. You can give it the equation. Right? So far, so good. Now we can determine the x-intercepts. How do you get the x-intercepts? Make y equal to 0. Okay, so basically h of x, so 0 is equal to 2 over x plus 1. Take the 1 over, it becomes negative x is equal to 2 over x. Take x over and multiply, divide both sides by negative 1. We get x is equal to negative 2. So the x-intercept is negative 2. So somewhere here, essentially. Okay, now we can draw it. So let's draw it. So okay, that was asymptotes done, intercepts done. The third step is determine the shape. So A is greater than 0. So since A is greater than 0, it's top right, bottom left. So let's look at top right. There are no intercepts here, so I just draw approximately what it's going to look like. Something like that, with the arrows indicating it goes forever, as long as you're not showing it's intersecting with the asymptote. And over here, I have to draw bottom left, but remember it has to pass through -2 because -2 is an x-intercept. So that's what I do. I draw it like this, and obviously I have to show that it passes through -2 and it goes all the way down. Let me just move it to show that. Okay, cool. And that is our sketch of this graph. Sketch of following graph with all the intercepts of the axes and asymptotes. This is what it looks like. Okay, cool. I think everything looks good. Okay, they say plot 3 other points. I would say at least it's not necessary unless the question mentions it, but you can plot like 1 or 2 other points. Normally they'll say just plot it with the axes and asymptotes, all the intercepts and the asymptotes. Okay, but if you want to plot a value, you just got to sub in an x value. For example, I can't sub in x is equal to 0 because that's going to give me an error. Look at it. If I sub in x is equal to 0, I'm going to get 2 over 0 plus 1. 2 over 0 is undefined. Clearly, that is why it's an asymptote. It's undefined. It's where the function is undefined. Okay? So, yeah. Let's look at this example, finding the equation. So here we are given a graph. They say, determine the equation of, here's the graph. So right here, we can see a horizontal asymptote. And it's passing through +2. Remember, so that's therefore its equation is y is equal to 2. Horizontal asymptotes are horizontal lines which take the form y is equal to the y-intercept or whatever y value there is. Okay, so we know the horizontal asymptote, which is essentially q. So remember, this is a hyperbolic function. Okay, it has two parts. Okay, visually it's definitely a hyperbolic function. So it's y is equal to a over x plus q. So we already know from the graph that y is equal to a over x plus 2. We know a part of it. Okay, where did we get 2 from? Yeah, we know that the horizontal asymptote is that value. Apologies, just give me 1 minute. Okay, so I'm back. Right. So we know part of the equation because this is the horizontal asymptote, Q. Okay, so we can fill it into the equation as Q. Now, what's left to solve for, okay, is A. So now we need to solve for A. How do we solve for A? So that was the point of why they gave us the additional, what do you call this? Coordinate 4 and 3. So we can substitute it in, and our only unknown will be A, and we can then solve for it. So whenever you have one unknown in the equation, you'll need an extra coordinate to sub it in to solve for that unknown. And here they gave it in the form 4 and 3. So y is equal to 3. So let's do this. We sub this in 3, 4, okay, plus 2. Take it over, it becomes 3 minus 2 is equal to a over 4. 1 is equal to a over 4. A is equal to 4. So now we've solved for the entire equation. Y is equal to 4 over x plus 2. Okay, so all it took was knowing the asymptote and solving for A as well. Sorry, 1 second. Right. Now, okay, cool. Right. So if you have any questions, then just let me know. But basically, that's how we solve for the equation. We know we have to be able to look at the diagram and determine if the horizontal asymptote is given, we know Q's value. Then one more coordinate will be given so that we can sub it in and solve for A. Okay, cool. Perfect. Let us move on. Let us talk about the exponential function. So we're moving on from the hyperbolic function to discuss the exponential. The hyperbolic function, okay, is what? The hyperbolic function is the weird graph with two things as well as two asymptotes. It has two parts to it and two asymptotes. Now, the exponential function just has one asymptote and one part to it, right? So here are a few examples of it, but let us talk about the equation. So the equation looks something like this. We have, 1 second. Okay, we have it in the form y is equal to a times b to the power of x plus q. A times b to the power of x plus q. 1 second. Okay, so now, I'm sorry, I'm getting very distracted. Okay, so now, right, let us talk about the parameters. Okay, so firstly, we have A. And what does A do? Okay, A and B, both of them help us to determine the shape. Together, their values help us to determine the shape. A and B together help us to determine the shape. And what about Q? Okay, Q is the horizontal asymptote. Q is the horizontal asymptote. Okay, and its equation is y is equal to q. Okay, now this is the equation. Let's have a look at what the diagrams look like. Okay, so we have multiple options. Okay, right here, y is equal to, so we have when a is positive and b is greater than 1. And here we have when a is positive and b is between 0 and 1. And I'll give it in terms of examples and hopefully it makes a little bit more sense. So right here, an example for this equation would be y is equal to, let's just say 2 times 3 to the power of x plus 1. So in this example, right, I have 2 as a, which is a positive number, positive 2. It could even be positive 1. And I have 3 as b, which is greater than 1. So 3 to the power of x. Okay, plus 1, and 1 is the horizontal asymptote. What would an example for this equation be? Y is equal to a positive a value, so even just positive 1 times b to the power of x, but b must be between 0 and 1. So it's a fraction, a half to the power of x, okay, plus 1, for example. So of course, this could just be written as half to the power of x plus 1. It's the same thing. Half to the power of x plus 1. So this is an example, and we'll discuss what the differences are of these two. So a is positive for both of them, okay? And when a is positive, okay, let's just do this. Let's just do this. Green. Let's do this. Red. Okay, when A is positive, okay, what does it mean? Let's do this again in blue, sorry. When a is positive, this means that the function is above the horizontal asymptote. Above the horizontal asymptote. So in both examples, the function is above the horizontal asymptote. So as you can see, if we compare these two functions, the first one we went through and the second one, both of them are above the horizontal asymptote. Okay, cool. So how does B affect the shape? In this particular case, if B is greater than 1, the function is increasing. But in this particular case, B is between 0 and 1, and the function is decreasing. Okay, so that's how it's affected. A tells us whether it's above the horizontal asymptote, and we'll do the examples with negative A where it's below. And B tells us whether the function is increasing or decreasing. And while being above, if B is greater than 1, it's increasing. And while being above, if B is between 0 and 1, it's decreasing. Let's look at the next examples. Now, in this particular case, A is negative. So A being negative indicates what? A being negative indicates that the function is below the horizontal asymptote. And in both of these examples, we see that case. The function is below the horizontal asymptote. Okay? And we talk about, what is this? B being greater than 1 in this case, and B being between 0 and 1 in this case, and it differs. Okay, so when A is below, meaning A is negative, but B is greater than 1, then the function is decreasing. But if A is negative, meaning below, and B is between 0 and 1, then the function is increasing. So it's opposite to what we had above. Because here when B is greater than 1, it is increasing. But here when it's between 0 and 1, it's increasing. Here when it is between 0 and 1, it is decreasing. But here when it's greater than 1, it's decreasing. So we must pay careful attention to A. A tells us whether it's above or below. Thereafter, we look at B. Is B greater than 1 or it's between 0 and 1? And then we can determine the shape. Let's do example equations for this one. For this one, we could have y is equal to negative 2 to the power of x plus 1. So in this case, just be careful. It may look like B is negative. B is never negative. This is actually the same as y is equal to negative 1 times 2 to the power of x plus 1. So we can see that A is negative, B is greater than 1. So that's what tells us the shape. A negative, B greater than 1, we must memorize that is below the horizontal asymptote and decreasing. It's best to memorize this table. It makes life a lot easier if you memorize all of this. Okay, let's do an example equation for here. A needs to be negative. So y is equal to negative 2 times B must be between 0 and 1. So it must be a fraction, a half to the power of x plus 1. So in this particular case, we can clearly see that A is less than 0 and B is between 0 and 1. And the horizontal asymptote actually is y is equal to 1. Okay, now that being said, let's go ahead and look at some examples. I hope this makes sense. This is very important and best to memorize. Let us talk about sketching the function. So there are 4 steps. First, you must determine the asymptotes, determine the intercepts, determine the shape. Okay, use table method to plot at least 2 other points. That just depends on what the question says. Right. Sketch the following graph showing all the intercepts with the axes and asymptotes. So Firstly, we must decipher. Remember, the original equation is y is equal to a times b to the power of x plus q. We already know that q is 0. A is actually 1. Be careful. A is not 3. A is always the coefficient and b is the base of the exponent. So even if there's a negative in front, b can never be negative. Okay, b is always greater than 0. It's either between 0 and 1 or it's greater than 1. But a can be negative. So a in this case is 1. B is 3 to the power of x. So a is greater than 0 and b is greater than 0. So a being greater than 0, we have above the asymptote. B being greater than 1, sorry, I'll change it to greater than 1, means it's increasing. So let's draw it, and we can draw our asymptotes. So the asymptote is 0. So essentially what? Y is equal to 0. Y is equal to 0 on the x-axis. So we draw it here. That's our asymptote. Hopefully that's visible. Now we need to draw our function. What does that look like? It is, so before we draw a function, actually, right, let's look at the steps one more time. Determine the asymptote. So we did that. Y is equal to q. Y is equal to 0. Determine the x and y intercepts. So let's try and do that. How do you determine the y-intercept? Make x equal to 0. So what is it? Y is equal to 3 to the power of 0, which is equal to 1. Let's determine the x-intercept. Make y equal to 0. So 0 is equal to 3 to the power of x. And this is not possible. Okay, we can't get 0 here, and it makes sense. Why there can't be an x-intercept? Because there can't be an x-intercept because the x-axis is an asymptote. Okay, it can't touch the x-axis. Okay, so we know that at y is equal to 1, we have an intercept there. Then how do I have to draw my function? I need to determine the shape, step number 3. The shape is determined by a and b. A is greater than 0 and b is greater than 1, which means above and increasing. So that's how I draw it. Above and increasing, and I just have to make sure it passes through the y-intercept. It doesn't have to be perfect. It just has to look something like this. Okay, and that is it done. This is the equation for y is equal to 3 to the power of x. Okay, let's have a look at this. Sketch the following graph with all the intercepts and axes. Right. So remember the normal equation is what? Y is equal to a over x plus q. I am off my mind. Y, that's hyperbola. Y is equal to a dot b to the power of x plus q. And our equation is y is equal to a half to the power of x minus 2. So what is a? A is equal to 1. Basically, a is greater than 0. What is b? B is equal to a half. Basically, b is greater than 0, but less than 1. B is a fraction. And this one is a horizontal asymptote, and y is equal to negative 2 is its equation. Let's determine the asymptotes, sorry, the intercepts. X-intercept. So 0 is equal to a half to the power of x minus 2. 2 is equal to a half to the power of x. We need to write 2 with the power of a half. I believe it's 2 to the negative 1. Okay, so I can write, no, what do I need to do? If the exponents are unknown, I want the same basis. Yeah, so if I have a half to the power of negative 1, then I get 2. So 2 can be written as a half to the power of negative 1, and this is a half to the power of x. Since my bases are the same, They cancel, and I get x is equal to -1. This is my x-intercept, so therefore it's -1 and 0. Let's talk about y-intercept. Make x equal to 0. So what do we have? We have y is equal to a half to the power of 0 minus 2, which is basically 1 minus 2, which is -1. So it's 0 and -1. Now we can obviously determine the shape, but let's just plot. Let's draw our asymptotes. So the asymptote here is just 1, -2. Let's say something like that. -2, or we can even say y is equal to -2 as the equation. Now we have intercepts, so let's draw those. That we know the graph needs to pass through -1 and 0, which is here, and 0 and -1. Something is wrong. No, nothing is wrong. So it needs to pass through those 2 points, right? Now let's look at the shape. Okay, a being greater than 0 means above. Let's do this. Above horizontal asymptote. While it's above, if b is between 0 and 1, it means that it's decreasing. Just memorize it. Okay, now we can draw it, make sure it's decreasing and above. So I'm drawing it above, and I just need to make sure it's decreasing and it must pass through both intercepts. Right, so this passes through both intercepts. I'm just going to lie and move my intercept and pretend that that is where -1 is, and that is where -1 is. I'm going to say this is obviously -1, and this is also -1. Okay, and this is my equation for y is equal to, sorry, just give me 1 second. Okay, sorry for the interruption. Okay, so yeah, like I was saying, this is how we sketch this function. And this is the function for y is equal to a half x minus 2. Okay, so essentially what you want to do is you're first going to plot your asymptote, which you get from -2. Y is equal to -2. It is a horizontal line, a horizontal asymptote. Thereafter, you want to determine your x-intercept, your y-intercept, if it exists. And then you want to determine your shape. So once you plot the x and y-intercepts, and you want to determine your shape, and then you can draw it. Okay, so make sure to practice a few examples to get the hang of getting the shape right. Okay, so you've got to pay careful attention to what is A and what is B, and then you can easily determine your shape. Okay, let's have a look at this last question, finding the equation. Okay, so it's solved in these 3 steps. First, sub in the asymptote, y is equal to q, sub in the y-intercept to find A, sub in another point to find B. So let's have a look at this example. We have f of x is equal to b to the power of x plus q. So in this case, it's safe to assume that A is equal to what? A is equal to not 0, A is equal to 1. It doesn't affect it, it doesn't exist technically, but it's just 1, and basically A is greater than 0. And we can see that, here's our horizontal asymptote, and we can see that A is greater than 0 because the function is above the horizontal asymptote. Now, they've given us another point, which I believe is here somewhere, which is 2 and 15. We know that y is equal to -1 is the horizontal asymptote, which is this dotted line. This is the horizontal asymptote. So we know that q is basically the horizontal asymptote. So we know part of the equation. Y is equal to, let's do this, y or f of x, same thing. Y is equal to b to the power of x, what? Minus 1. So that's step number 1. First sub in the asymptote y is equal to q. So we know the asymptote, so we know q. Now we have the case where we have an unknown. So we need an extra coordinate, x and y, to substitute in. That's why they have given us 2 and 15. So we take 2 and 15 and we sub it into this equation, where y is 15 and x is 2. Okay, take 1 over to the other side. It becomes 16 is equal to b squared. Square root both sides. And you're going to get b is equal to plus minus 4. So we have 2 options for b. But which one would we choose depends on the shape. Again, remember A and B helps us to determine the shape. So now if we're working backwards from having the shape to determine A and B, all we need to do is look at the shape, and that will help us to determine what is B. Is it going to be, should it be positive or should it be negative? Well, either way, actually, B should be positive because B is never negative. So B is equal to 4. Okay, A is the one that can possibly be negative. B is never negative. Okay, so we get 4. B is always greater than 0, so therefore B is equal to 4. So now we have solved for the equation. Why? Because the equation is y is equal to 4 to the power of x minus 1. Okay, that is the exponential equation. Let's have a look at this one. Okay, so it's the same process. You can literally, if you want to pause and do this yourself, then you can just do it. Okay, then come back afterwards when I've done it to check your answer. So we have y is equal to 2. This is definitely a horizontal asymptote. We can see by the fact that it's represented by the dotted line. The asymptote is a point on the graph, basically a point on the Cartesian plane or a straight line that the function of the graph never touches. Okay, it is what makes the function undefined. So here we know that the equation of the horizontal asymptote is y is equal to 2. That was given. So we also know that q in the function is equal to 2 because q is our horizontal asymptote. So let's sub that in. We have y is equal to a times b to the power of x. Okay, b to the power of x plus 2. Okay, then we know 2 coordinates. Okay, so here we know that A is greater than 0 because this graph is above the horizontal asymptote, but we can't say that A is equal to 1 for sure, but we just know that it's greater than 0. In fact, we also know B, what is the value of B? Okay, we know that B should be, so it's above, meaning A is greater than 0, and it's increasing, which means that B should be greater than 1. Okay, that's something we know. We don't know its exact value, but we, for now, know just that. So, in this particular case, we have two unknowns, A and B, but we also have two coordinates given. So let's substitute them in. The two coordinates given are, let's start with 1 and 10. Okay, we have 10 is equal to A times B to the power of 1 plus 2. Okay, so this gives us, if I take 2 over to the other side, becomes 10 minus 2, 8 is equal to AB. Then I have my second coordinate, which is a y-intercept of 4. So that means the coordinate is 0 and 4. And I have y coordinate 4 equals to A times B to the power of 0 plus 2. Now, B to the power of 0 is just 1. It has a value of 1. Take 2 over to the other side, becomes 4 minus 2, which is 2. And I'm left with, okay, let's do this one more step. 4 minus 2, which is equal to 8 times 1. So therefore, A is equal to 2. I can substitute A here. 8 is equal to 2 times B. Divide both sides by 2. This cancels with that. And I get B is equal to 4. Okay, so A is equal to 2. B is equal to 4. So two unknowns, that's why they gave us two equations. So I know my formula. It's y is equal to 2 times 4 to the power of x, okay? And q we got from the graph, so plus 2. Okay, cool. That is the equation of this exponential function. So we given the diagram and we asked to draw the function, we given the function and the diagram, we asked to solve for the equation, find out what is the equation. The first step is to first sub in the asymptote y is equal to q, sub in a y-intercept to find A, sub in another point to find B. So if A is unknown, sub in the y-intercept, because x is 0, with the y-intercept, x is always 0. So x is 0 here will always turn this value into 1 because anything to the power of 0 is 1. Okay, but technically either way, you could do it either way. Okay, it's just that once we solved for A, we sub it into the other equation that we solved. It's essentially two unknowns, they give us two coordinates. Okay, cool. So let us call it there. Please, if you have any questions, just message me. But yeah, I'll see you guys in the next lesson, which is this weekend. Yeah, Jazakallah khair. Assalamu alaikum and goodbye.